Yeah, so thank you. It's 10:30. Thank you for joining this session. I know looking at the graph out there, the number of people involved in just the straight up, game development versus architecture, engineering, and construction and other disciplines, we're still kind of in that small niche category. So happy to see so many people actually show interest in the space that we're actually operating in, which is, thank you.
Thank you.
And you'll see from our background, we've been involved in this space for a bit. We're kind of
Yes.
coming from an architecture engineering background, but also gaming and like what happens when we merge these two backgrounds. So we'll jump right into it because we have 50 minutes and we got a lot of content. We're gonna get into like live demos and show some of the work we've been developing. But really the concept here is, kind of anticipating the metaverse-like experiences, but specifically for architects, engineers, and builders. How can you get these engineering-grade models to operate inside of something like Unreal Game Engine? So we're going to go through an intro, a bit about what is Bentley Systems, like who are we as a software company, what was the challenge that we took on as a team, our innovation team, what was a case study. We actually worked with a very large project in France, which we'll give a demo of today. Then Danny will get into the actual solution live demo of the tech we've written that works with Unreal Engine. And then we'll talk a little bit about how we see this kind of evolving into the metaverse for this more or less industrial use case rather than the straight up gameplay. So quick introduction about myself and Danny. So we are a bit of a convergence here of, on the one hand, myself coming from 20 plus years of software design in the BIM space. So if anyone's familiar with like Revit, for example, any Revit users out there? So I spent really the beginning of my career designing like Revit and then working for Autodesk. And then I progressed into another startup, which was Synchro. Is anyone familiar with Synchro? Okay, cool, it's a few people. It's a 4D construction animation simulation tool for contractors. And then I joined Bentley Systems. And then I started an innovation lab. And this is where then Danny comes in. So I started to look at like, okay, what is it? How do we kind of like shake things up within Bentley, and then found Danny. So maybe.
Hello, I'm Daniel. My background is a little bit different. I'm a software engineer, and I spent the first 10 years of my career just doing video games, from indie games to AAA games. And after that, I saw opportunity on WebGL. When WebGL appeared, that was like 10 years ago maybe. So I founded a WebGL company to do storytelling directly in the browser. So we had a WebGL platform, so you could upload files from Revit, SketchUp, and 3 Studio Max, and you could create real-time experiences without programming. So we got even like, I have plenty of stories there, many years. We even got investment from Chaos Group, the guys from V-Ray, but unfortunately we ran out of money, and the team was acquired by Esri. So at Esri, we developed the ArcGIS plugins. I work a lot with, I developed the Unreal plugin. And then after a couple of years, the plugins were already done, and then I joined Bentley. So it was a great opportunity because I could kind of mix all what I had learned in game engines, WebGL, cloud, digital twins, and geolocation. So I guess the work we are going to talk today, to present, it's going to highlight that.
Yeah.
Thank you.
So that's kind of the interesting combination, like a gaming background and sort of in like architecture, engineering, construction. And we think that's actually a nice, we'd even like think about what's the relationship between Epic Games and Bentley Systems. On the one hand, game engine development platform, all the value that brings to it. And then Bentley Systems, which is really a CAD-oriented market, right? Explicit 3D CAD models. What does it mean if we bring these two disciplines together? And it's a little bit about even like Danny and I and our relationship. And so here's kind of the context. So our customers, and maybe many of you here, their day job is actually building 3D models of 2B architecture, or in our case, infrastructure projects. Everything from wastewater treatment plants, and I'll run the video here, just shows examples. These are actual models that our customers produce with the software. So it's architecture, it's stadiums, it's dams, it's hydroelectric plants, electrical facilities, nuclear engines. I mean, so like the whole thing. So anything that's sort of physically around us that's built, that we occupy, and the supporting infrastructure is what our customers are building as a part of their daily work. So it's kind of interesting for us as a software solution company working with Unreal Engine now, we don't really have a content problem. Like our customers are producing the content, the 3D models, just as a function of their daily job. What they don't have, though, is an easy way, until like we're going to show you today, to get all of that investment in 3D. How do you get that into a game engine, right? And start to get an experience of like real-time animation. So this is our innovation process. I run an innovation team at Bentley Systems where we say, the task we took is how do we take these big models and let's experiment. So the test was, let's get our hands on some big, hairy, challenging 3D models, the biggest ones we could actually get permission to use, start experimenting. So Danny just started with basically open box. It's like, here's the models. Okay, you figure this out. And we said, we're going to use Unreal Engine as our dev platform. We kind of shifted from Unity. We said, let's use Unreal Engine, see what we discover out there. We also said, we're going to not just go after laptops, but we also said, let's target Oculus and see if we can get that 90 frames per second off these models, kind of like raise the bar a little bit. And then take it out into the field and expose all of this to end users and see what's the feedback. What do they think about that? And so here's what we found. The pain point we have discovered with almost all of our customers when they're in their authoring applications or trying to share that content with their stakeholders is they've got poor frame rates in the authoring tool, and then when they try and get that experience into other people's hands, also a reduction in frame rates. If they do need to go to Unreal or Unity, there's a massive optimization pipeline, exporting files, optimizing it manually, producing a game, and there's this entire cycle. And if the model changes any time in that process, there's a huge delay. So it can literally take days, if not weeks, to go from that 3D CAD model into a high frame rate experience inside of Unreal Engine. And so what we saw with our customers, they end up downsampling the whole experience, that investment in 3D, to video or image. So 24 frames a second video are just static renderings. And what do you get with a static rendering? It's just pixels. There's no interactivity. You cannot zoom into a video. So I think everyone's probably familiar with this process. Get the file, export it, do some optimization work, publish the app, get it out into people's hands. And if there's any change in the 3D model in that process, you kind of like are starting over from scratch. So that's a file-based workflow. And so we said, what's the challenge here? We want to kind of eliminate that workflow, make it fast for our customers to go from the 3D engine into an experience, an app built with Unreal Engine, and deliver this high frame rate without having to go through any manual optimization. So model to the extreme level of detail that you're modeling, and let's assume that we can get that running at high frame rate. And we're also going to make sure that this works on standard issued laptops and headsets. So these are the use cases we discovered, mostly around design, coordination, things that happen in the field during construction, and also presenting this work to stakeholders. So architects, engineers, contractors, sharing the state of that construction model, that design model, and then getting feedback from their users. And I'll move here a bit, move quickly here. So this is the actual project. So we started working with this project in France called ITER. And ITER is this experimental fusion reactor being assembled in southern France. 35 countries are working on it. If they do manage to build this thing, which is a bit crazy, it actually creates the conditions of the sun inside the tokamak reactor. So the temperature is insane. It's all managed with like high-powered magnets to keep the fusion kind of suspended, and that it can produce like a huge amount of carbon-free energy. So that's the site. It's a massive construction site. The scale of just the tokamak that produces the fusion is like 60 meters high. So it's the size of an entire building. So there's a photo shot, there's the shot. So this is the project. So that our customer are modeling all of that with engineering grade precision 3D models. In this case, inside the facility using CATIA. This is for scale. There you can see the scale of the human figure. So just the machine itself is like bigger than most buildings. And all of that is detailed and wired with like lots and lots of polygons, millions and millions of polygons. So that was the challenge. Like, can we get this reactor running inside of Unreal Engine? We actually went on site, and this is what it's like inside the building. So it's really like a huge assembly hall, legitimate piece of architecture, massive scale. And this is that downsampled version. So the client, Brigantium, their task is every 2 weeks they deliver an animation video showing what is the sequence of construction that we're planning for the next 2 weeks. So that's actually produced on a regular basis, but of course, no interactivity. You have to like render it out and then deliver it to the user. You can see even the graphics here aren't even that great, but that's sort of business as usual. That's what they deliver to the client. And then we went into the field, and we also noticed this, like just a sense of scale. There's some workers climbing up this. And this also got us inspired to think, imagine if you could actually have a VR experience and like fly through this model without having to put on all this PPE gear. So that sort of sets up the stage for the challenge. So we knew we can get 3D models, and this is technology that Bentley's produced called the iTwin platform. It can consume and federate a wide range of 3D BIM and CAD formats. It's not exclusive to Bentley. So we can pull in the CATIA files, the Revit models, Navisworks, and they are federated and stored as data in the iTwin platform. And we knew we had Unreal Engine on the other side, where we know if we want to get this into a device, an Oculus, a HoloLens 2, an immersive experience, we've got that on the other side. And so that was the challenge, and that's sort of now I'm going to hand it over to Danny, because then that was the setup for like, here's the project, here's the use case, here's the actual challenge. How are we going to bridge that gap between these 3D models and the game engine?
Yeah, so in theory, the problem is very simple, right? You have a designer or an engineer that is working many pretty complex projects. And what she wants is to share those models for a myriad of use cases, like different teams, like other designers, workers, etc. And that people is going to use like from tablets to big computers like laptops, etc. Right? So how can she just make those models available for all that people? So I'm going to talk about the first piece. That's what Greg was talking, which is the iTwin platform. The iTwin platform is a digital twin platform in the cloud. So it can federate 3D models from very different applications. What that means is, briefing, is that all those models are converted into a database. The good thing of that is that you have all the metadata, all the engineering-grade data, et cetera, and also the different models can be combined and aligned into a more complex digital twin. Problem here is that, okay, that's fantastic to keep the data, but how do you visualize that? For that, when I joined Bentley 1 year ago, we were like brainstorming how to do that. So we came up with a technology we are going to present today, which is 3DFT. 3DFT is a codec that what it does is it takes the original data and streams that directly into the different devices. How we do it, I'm going to talk about that later, but basically the data that you have is the original one, and there's a smart process that optimizes the whole process. So it's like what you see, like YouTube, right? But in YouTube, you can see the videos like stream. So this is not pixel streaming, it's that stream, and get into that, but that's a little bit the brief concept. And one thing very important, which is Unreal Engine, right? We're talking about the data, but you need like a very important, like very robust tool that gives you the ability to export to different devices, high frame rates, what is very important, high quality. So this is basically an example of the ITER, the digitalized ITER. Now we are going to get into a demo.
Yep. So there you can see, actually, we have the model running the full campus, including the assembly hall. And I'll just launch the demo. This is just showing, we cut this video just to show like the wireframe, just to see the raw density of triangles in this model. That's a video, and now I want to jump into an actual like app that we built off this data set with this 3D-FT.
And
Okay, here we go. So that's loading up from the server and loading up automatically into this laptop. And by the way, I know this is like a more powerful machine here, but this app runs on basic laptops, CAD laptops. You don't have to have a super high-powered machine to actually start navigating through this model. And the 3D-FT codec, which Danny will get into technically in a minute, is actually running here in real time. It's hard to tell. Sometimes you can catch it, but there's a bunch of LOD meshes that are being delivered at runtime that make this smooth navigation possible.
yes, what you see here, all the data, all the different LODs, etc., all that is streamed in real time. So you don't have to optimize anything. And the cool thing is that what you see here, there's zero optimization. I mean, these models are crazy because they are created for engineering, design, and for construction. So we'll get into numbers later, but we're talking about 1 million elements here. And
Just real quick, is the
yes.
codec available? I know there's probably people thinking in the room, separate from iTwin, or is the codec integral to iTwin?
It's as of today, it's interoperable with iTwin.
But is it integral?
Uh,
Do we need iTwin to use 3D-FT codec?
yes, today, yes.
At the moment, yeah, because basically the iTwin platform is where we federate and normalize all the CAD data into one
Yes.
common schema, and then the codec can then hit that endpoint, and then it produces all this kind of magic after the fact. But that's a really good question.
One of the important things that you hear that we'll get into that later is that as you move, the new LODs are being streamed. So at the first version, you could see the change better. Now it's fast enough, so you can appreciate that sometimes, but in general, it's fast enough. So you don't see the difference. So that's why it's so fast. So it's not magic or anything. It's just that what you're rendering is very compensated the quality to the distance of the object that you see. And of course, yes. It's this is in Unreal Engine. Yeah, it's a plugin. It's a plugin inside Unreal Engine. So I will say, it's a codec. I'm going to get into that just in a moment. That's 503. Yes, I tried that in 5.1, but I thought it was a little bit too risky for today. Yes.
Live dangerous.
Yes. I mean.
Cool. Okay, so that's the app.
Yes.
Yep.
Yeah. So what I was saying, because so it's a fundamental change in the way that we are visualizing models, because we are talking about what I was saying before. It's cloud-based. It supports instant changes. So what we are talking is that in the cloud, you do a change, and it automatically updates the 3D model, and then you consume that. Of course, with Unreal Engine, you have the looks, you have the performance, and also it supports dynamic content. So our plugin is all based on dynamic geometry. Of course, it supports multiple devices. And then the 3D-FT codec is what is the magic sauce of all this. So it's very performant, even with huge models. It supports direct cloud streaming, not talking about pixel streaming, I'm talking about 3D data streaming. And the encoding process is very fast. That's also very important, because let's say that the optimization takes 6 hours, then what's the point of all of that? Okay. Oh, yes, let's click on here.
Oh, there we go. Yep.
Yes.
There we go.
Okay, so what's a codec? I call it a codec because I think it's, when we talk about video, a video codec, I think it explains quite well what it does, right? With a video, first you encode the video into file format, and then you need a decoder that renders that. So not pixel streaming again. So the encoder, what it does is it takes the original model, it splits it in parts, and calculates the different levels of detail. How it does it? Completely automatically. So some like retessellation and decimation, all that is part of this process, and 3D compression. The file format, it supports, one thing that is very important is that all the pieces are uniquely identified. So this means that the model doesn't change. It's not a copy. It's basically the original model. And it's optimized for cloud storage. So we are just thinking about the cloud because it's the only way that you can easily share this content and communicate with different people. AR, use cases, design review, anything has to be connected. This is how we envision digital twin, connected digital twins. And one thing that you see, and even there are things like 4D animation that is supported. So, but 4D animation, of course, can be stored in the format, but it is not because you can have service that, let's say that you have a service that changes the scheduling in real time depending on, I don't know, something that you change. So we can instantly get that information and create the 4D animation. It's something that he was talking before about the videos. A video, it's all done, right? When you do a video here, you can do you can do simulations, etc. And then it comes, and then it's the decoder, which is that's a plugin. That's a part that plugs into Unreal. And I will say it's kind of a data engine or a decoder that is the one that selects which parts it downloads from the cloud. And it has smart algorithms to divide everything in pieces so the camera frustum gets in. So it's in a way, it just collapses geometries in a smart way. So getting into details will take more than this presentation. But the decoder is the one that takes all that information and creates the geometry inside Unreal.
Now it actually runs in the editor, which is quite impressive.
Yes. OK. Unreal Editor. Let's open some. I'm going to open just a few examples that we are allowed to show. So let's start with this one. Yes?
Yeah.
Yes, we'll get into that later. Mm-hmm. Yes. That's a good reason why we don't do that. So here, for example, you can see the detail. All this, what you're seeing here is streamed from the cloud. That's important. So again, this is not about what he was talking before about creating an application that you ship. It's about consuming models directly. So we are just showing that in the editor because it was a good way to load different models. So all these models are between 40, 60, 90 million polygons. And as you can see, they run and load very fast. You can see here, for example, the parts being loaded. That's where the streaming gets in.
It also meant that once it's in Unreal Engine in the editor, then we can start to augment that scene with other content. So we can link in like geospatial cesium tiles. We can drop in metahumans. You could add additional content. So then you've got this base layer of like everything else you can do with Unreal Engine, but then we sort of guarantee that these huge models you won't have to worry about. They're gonna run with this codec. And then you can start to augment that scene as you see fit, build colliders, build UX around that.
How do you deal with so if you've got colliders or materials on objects that get removed?
Yes.
Back in the UUID or something like that, I guess.
Exactly. Yes. We'll get into that later. I will remember the two questions. Nanite, I know Nanite materials updates. Yes. We will, at the end we'll go through that. So here you can see, and sometimes what you see here, one thing that is important is that we're not talking about models or measures. We're talking about scenes because what you see here are multimodal scenes. So when I was talking about federation is that, you have teams working different things. I'm sure that this part was done by different designers from the stadium, also the exteriors, etc. So those are like small examples of things that we are allowed to present. And as you can see here, like it's a 1 millimeter precision thing, a resolution. Okay, so let's get back to presentation. Yes, so what I was saying in editor, runtime rendering, very fast rendering. It works with VR. This is important because one of the important things is speed. It's so fast that you don't have to like manually optimize that for VR. It's also compatible with other plugins. So if you want to enrich context, what he was commenting before, with Cesium for photogrammetry, or terrain, ArcGIS, to motion with the humans, you can do that. We are supporting also blueprints for element selections. I'm going to get there. And we also support local cache like a browser. So the first time you access, it's a little bit slower, and then the local cache gets in.
What's your backend cloud rendering platform? Is it CloudXR for NVIDIA?
No, it's it's Azure.
Device.
Oh, you can just create an application directly, or stream directly to the glasses with Unreal, or
Yeah, no,
or.
I'll ask after.
Perfect. Okay. Okay. So some numbers. I think that what we've presented here is more on the bottom side, but we have some examples that unfortunately we could not present today. But you can see the number of triangles. We have projects of 356 million triangles, and they work very, very well. The encoding time, that's also important, because what happens when there's a change? Are we going to spend, as I was saying, hours waiting for that? No, we're just talking about seconds. I mean, we really put a lot of effort in the encoding time, because then we don't have to worry about what happens if something changes, etc. You don't care. Just wait a couple of minutes, and if you change anything, then you got it. Then you got it. And of course, those are the biggest projects. If you have smaller ones, it's faster. And another thing, one of the biggest problems that you have is with objects. Those models are composed by tiny, small parts. Because when you build, for example, the Ether, or when you're building anything, there are two things here. One is how designers design their models, and the other thing is how important it is for them to have information for every small piece. Then it's quite crazy, the number of objects. But you can have, for example, that theater, which is 50K, that's a dream. Normally you are in the rounds of the millions. All that is what 3DFT also optimized that. Okay, so one thing that is important is a switch of mind of how we are visualizing models. So when we think of a file-based workflow, what happens is what Greg was commenting before, is that you have many problems because you have to like optimize the model, then you have to package it, you have to like share that application every time. You have to do it per model, unless you do a very complicated processing which you merge different models, different scenes, et cetera, right? So for us, that's not a connected digital twin. When people talk about the metaverse, about digital twins, okay, what you expect is that you get the latest information, dynamic information, that's it. You don't want to get, this is not a video game, right? This is, what you want is basically consume those models dynamically from what I was saying from the database. Okay, so this paradigm shift, which is, now we are thinking more into a multimodal application. So the developer just creates one application, a viewer. Let's call it a viewer. Then, thanks to the iTwin platform, the designer or engineer, without any help, without having to rely on external teams or anything, she can just upload the model, update it, and that's it. Because the application is going to say, okay, just give me the models that you have, okay, and just visualize that. You don't have to manually create a new application or anything similar. All that is what we will say like metaverse style, but everything is cloud-based. And one important thing, we are talking about multiple models. So if I'm a developer, I'm going to create, let's say that I create you have a big organization that they have and multiple designers. They are working on different projects. What you want is you just create the application that automatically leads the different models. Some scenes are going to be composed by different models. Some scenes are going to be simpler. But you don't care. Basically, you just create an application that is downloaded once, and then the content is trained. So what I was saying, one simple application can visualize any kind of project. It's like a website, right? You get into a website, you have images, you have videos, but you don't care about performance. You just see that, and the browser just can visualize any kind of website. So it's or web page. That's the same concept. And things are simple, and like when there's a change, the platform just notifies you automatically, or notifies the users in your team. That's really handy. Also, automation. What we're talking about is everything is completely automatic, and I think that this is going to open a way of creating new applications that are going to reach like a bigger audience of users, because again, one developer, one company can create an application that can fulfill like many use cases without having to worry that much about the content. Other technical requirements, super fast. I was talking about 1 million precision, interactive measurements. So just as an example, for the animation. Let's see. Yes, so this scheduling is done in Synchro, and this model is very complex. We don't care. Basically, it gets the animation from the scheduling, and it shows it. And the number of pieces of this model is really high. We are talking about what I told you, I mean, half a million elements. But even that, the performance is very good. And this was super important because you have a team. He was talking before about the video. If you release a video, if there are many different teams working in different floor plans, they cannot see that. So they have to choose the perfect angle, etc. With this, you can do a change, and the different teams can understand and even zoom in and know what they are going to build today, tomorrow, next week. Let's talk about metadata. At the beginning, I was talking about databases, about original data. But what is the most important part here? That's the most important part here. When you click on an object, something that you can do, you have a unique ID. That unique ID is part of the database of the digital twin. So what you see here, I mean, it depends on the designer how it groups the model. But let's just look at a simple example. Here, you can select one seat, right? You could connect with that ID, you can connect that seat to whatever, like how many people has been using that in 1 year, the price. You can know when it was COVID. I know that there's a company that was able to calculate the separation between seats because of the restrictions. That's the things that we have to do. So our objective was to say, okay, we solved the visualization for you, the federation. But now here is when you kick in, because then you have to start doing smart things, because a digital twin just for visualization is cool. But let's think a little bit more further. Is what can I do with a digital twin? And we know that if we have the information and metadata, then it starts to get funny. Okay, I pass that to Greg.
Thank you. Yeah, so that's kind of where we're at today. And then in terms of next steps, we feel like we've sort of solved this performance problem. So we want to actually publish this SDK for general use for any Unreal Engine developer that would enable the basic apps to be built for this market. I think also internally, we're looking at what would it mean for us, Bentley Systems, to build apps on top of this stack and deliver those to the market and keep innovating, and then help this idea of like, what is the metaverse, help it become real. So not necessarily like the game world of the metaverse, but like what does it mean to apply this game engine theory into this market segment? I think what's interesting, I think we're hitting some key requirements of what the metaverse is going to have to require, even to be considered a metaverse. So, one, interoperability. Like, we're quite open. We don't say that you must use a Bentley format to get in. It can be any CAD format. It's persistent. In other words, if that model changes and you open up the app, it's going to call the latest version from that server and just stream it in. So it doesn't have to be recreated every time. So it's live data. And of course, real-time rendered interactions, not video, real-time interactivity, which is really the meat of the problem we solved here. And also, we're saying, because it's Unreal Engine, we can target a wide range of devices. HoloLens, Oculus, Vario, you name it. And so just as a couple experiments of what we're just sort of testing the waters. Now we sort of got this performance problem solved. Well, you can start to drop avatars in, not a big deal. It opens up that door to start experimenting with what that means. If you now enable that with multi-user gameplay, the whole idea of a design review completely changes. Like, we can have the entire construction design team in the model with avatars reviewing it at scale. And so this is what it looks like against the Oculus. Again, the beauty of using Unreal Engine, very easy with templates to start deploying on different hardware profiles. So we've built apps here where you can navigate through in VR inside the reactor. We've also tested this with multi-projection screen systems. It just works out of the gate. So if you don't have the ability to if you want to get full immersion, it absolutely works on kind of like large format projectors to give you that one-to-one scale rendering without going all into immersion. And it works with the HoloLens, the whole technology. Here you can actually see the setup. The app's running locally on that laptop and just streaming over Wi-Fi into the device. So we're not actually running any apps in this case. And there was a question out there. The app, in this case, it's not running on the Oculus or the HoloLens. It's all running locally and then streaming over Wi-Fi into the headset.
So it's not running on the Quest native then?
It's not native. It's all air-linked and streaming in. And then the geometry is kind of pulled in from the cloud into the local laptop and then streamed into the device. So I think that gives us some time for some questions. I want to move through that quickly. This is, if anyone does want to get involved, this QR code will go to a form. And if you fill out that form, just name, email, address, that'll kind of get you into kind of the pipeline for like early access development. And then we can reach out to you. So I would use that. That's a quick way to get into the system. And then, of course, you can also contact Danny and myself through LinkedIn. We're going to be at the event all week. And we've also got two of our developers here in the audience. Danny, who just joined, and Marcus. Where's Marcus? Over there, yeah. So we have four of us here. That's sort of the team. So we'll be here all week. And yes, thank you so much for your time. And